Okay, welcome back to BIS channel. In this lecture, we are going to discuss dimension modeling. So, you have to start with the Kimball life cycle. So, this is your targeted block, dimension modeling. Okay, in previous lecture, you have to discuss technical architecture design. Uh, there are two different videos. Next one is the dimension modeling. So from Kimball, from business process to dimension model. Suppose this is simple program. So program is divided into different projects. Then projects may be divided into different business processes. So one of the business process, it's once again divided into facts. Okay. So this is simple example. Okay. This is program. So there are different labs. So there are different lab sessions and there are different login time minutes. Okay, so this is simple example. So there are different key terms you have to used in the dimension modeling. You can correlate with requirement analysis and design and implementation. Whenever you have to say business process, it's nothing but fact table. So fact is nothing but column in dimension table. So next part, dimension is nothing but dimension table means. Okay, then dimension model, it's nothing but star schema. Then next, business process, it's nothing but user. A dimension, it's nothing but a foreign key. Okay, so making the case of dimension modeling. So dimension modeling names DM is a set of techniques and concepts used in data warehouse design. So dimension modeling is one of the method of data modeling that help us store the data in such a way that it is relatively easy to retrieve the data from database. So dimension modeling always use the concept of facts, it's nothing but measures, and dimension, it's nothing but context. Okay, so dimension model, it's a denormalized relational model. Okay, made up of tables with attributes. Okay, so relations defined by key and foreign keys. Okay, so note next, benefits of dimension model, it's nothing but understandability. Okay, compared to normalized model, dimension model is easier to understand and more intuitive. Okay, so dimension model information is grouped into coherent business categories or dimensions, make it easy to read and interpret. So next one is the simplicity, also allows software to navigate database efficiently. Okay, next is the query performance. Okay, so dimensional model are more denormalized and optimized for the data queuing. Okay, so after that, the predictable framework of dimension model allows the database to make strong assumption about the data which may have a positive impact on performance. Okay, so query optimization is simple, predictable and controllable. Okay, next one benefit is nothing but extensibility. Dimension model are scalable and easily accommodated unexpected new data. Okay, so existing table can be changed. No queue is application that sit on top of the data warehouse, so no need to reprogram to accommodate changes. Okay, so this is the difference, means entity relationship and dimension. Okay, so data is stored in RDBMS. Here data is stored in RDBMS or multidimensional databases. Tables are units of storage. Here cubes are units of storage. Data is normalized and used for OLTP, optimized for OLTP processing. Here data is denormalized and used in data warehouse and data mart, optimized for OLAP. Several tables and chain of relationships among them. Fab table and fact tables are connected to the dimension. Okay, it's relevant to volatility okay, and time variant detail level of transaction data, non-volatile and time invariant. So those are some differences between entity relationship and dimensions. Okay, another difference. Okay, data model primer. So fact table, what is my fact table? Fact table keys, fact table granularity, dimension table keys, confirm dimensions, then 4 steps for dimension design process. Okay, so what is by fact? Facts are quantitative measures that we wish to analyze and report on. Dimension contains textual description of the business. They provide context of the facts. Okay, so this is the transactional database and this is the dimensional database. Okay, so you can check here in transactional, customer address is nothing but states, countries. Okay, so another uh, order header, order detail, products, but here you have to maintain data in dimensional table. It's nothing but star schema. So time, so you have to create id, customer id, okay, time id, customer id and product id. Okay, those are the foreign keys here you have to store and these are the primary keys. Okay, so fact tables, it's nothing but it stores quantitative information for the analysis and is often denormalized. It contains 2 or more foreign keys. Okay, tends to have huge number of records. Okay, so this is useful. Facts tends to numeric and additive. Okay, so fact table holds data to be analyzed and dimension table store data about the way in which data in fact tables can be analyzed. Okay, so fact table consists of 2 types of column. The foreign keys columns allows join with dimension table and major column contains data that is being analyzed. Okay, so this is the example of fact table. Company sell product to customer. Okay, so dimension attributes. Okay, so there are different attributes: verbose, descriptive column, complete, okay, discretely valued, quality assured, okay, business key, surrogate primary keys. Okay, so dimension table stores attribute or dimension that describe object in a fact table. The data warehouse organize descriptive attribute as a columns in a dimension table. For example, customer dimensions attribute could include first and last name, birth date, gender, etc. Or a website dimension would include site name and URL attributes. A dimension table has a primary key column that uniquely identifies each dimension record. It's nothing but row. Okay, so this is the example for dimension table. So dimension table, some description about dimension table. Okay, dimension table are referred by the fact table using keys. Okay, the surrogate key is used as a primary key in a dimension table. The surrogate key is placed in the fact table and foreign key is defined between the two tables. When the data is joined, it is so just as a other join within the database. Okay, so dimension table keys. Okay, so there are you have to use surrogate key. So advantages of surrogate key, it's nothing but performance, buffer from operational key management practices, mapping to integrated disparate sources, handling unknown or not applicable conditions, then track changes in dimension attribute values. Okay, so confirm dimensions, next one is the confirm dimensions. So it's nothing but standardized confirm dimensions are the goal for any well architected data warehouse. It's shared across the enterprise data warehouse environment, joining to multiple fact table representing various business process. So benefits of this: consistency, integration and reduce development time to market. Okay, so major 4 steps of dimension design process, first step is choose business process. So this is first step in design process, is to determine business process or measurement event to be modeled. Then declare the grains. Okay, once the business process has been identified, the design team must declare the grains of the fact table. It is crucial and crispy design exactly what the fact table row is in the proposed business process dimension model. Next is third step, identify the dimensions. Once the grain of the table is firmly established, the choice of dimension is fairly straightforward. It is at this point you can start thinking about foreign keys. The grain itself will often determine a primary or minimal set of dimensions, and at the end identify the facts. The final step in design process is to carefully select the facts or matrices that are applicable to business process. The facts may be physical captured by the measurements event or derived from these measurements. Okay, so you have to finish that part here. Okay, thank you.